Namaskar students. So in this video I am going to teach you about the IUPAC nomenclature of aldehydes and ketones and methods of preparation of aldehydes. Okay. So first of all we'll try to understand what are these aldehydes and ketones and carboxylic acids and why they are studied under one heading. Okay. So all these compounds, class of compounds, they have same functional group linkage C double bond O. They have same linkage C double bond O. So that's the reason they have put in one chapter. Okay. Then, so only aldehydes and ketones are neutral compounds, whereas carboxylic acids are acidic in nature. The reason is the carboxylic acids, they have one OH group on carbon and another one it may be hydrogen or any alkyl group. But in aldehydes and ketones there is one keto CO linkage, right? But aldehydes, they have both hydrogen, so one will be hydrogen and another one will be hydrogen or alkyl group. And in ketone, so both the linkage, both are the R group, means they may be alkyl or aryl group. Okay. So that is why aldehydes and ketones are again studied together and carboxylic acids are separately studied in the same unit. Next, coming to their nomenclature system, so aldehydes are generally named as alkenes. The name of alkane is derived from the number of carbon in the chain, and to that Al is added by removing the E, so that becomes alkenal. Okay. So here you can see that alkenal. Right. So coming to ketones, so one thing I want to say is aldehydes, they are terminal groups and no need to number them. Okay, if at all there is one more group, so if you want to number, so again number the chain by considering the carbon of the aldehyde group as 1, because aldehydes are terminal groups. Then coming to ketones, so ketones are named as alkenones by removing the terminal E of the corresponding alkane, one is added, so that becomes alkenone. And ketones comes in between the chain, so numbering is important. So when you number the chain, you have to number the chain so that the carbon of the keto group gets the least possible number. So the name becomes alkenone. Okay. The name becomes alkenone. Sorry. The name will be alkenone. And for aldehydes it is alkenal. So coming to the methods of preparation of aldehydes, so first one is from nitriles. It is called Stephen's reduction, so in which nitriles are reduced using stannous chloride in constant HCl. It forms imines. So where there is carbon double bond N, it is called imines. Okay. So which all acid hydrolysis forms aldehydes. So this method is generally employed to reduce the any multiple bond. Okay. So to selectively convert the nitriles into aldehydes, we have to choose diisobutyl aluminum hydride. And they selectively converts into aldehydes. Means if there are carbon-carbon double bond and carbon-carbon triple, so carbon nitrogen triple bond, then this DIBAL hydride, diisobutyl aluminum hydride, will selectively reduce only C triple bond N, means nitrile, to imine. So in the example you can see there, so pent 3 nitrile is converted to pent 3-enol, means we are not at all disturbing this C double bond C, so it is retained in the product. Okay. So Stevens reduction is just converting nitriles by reducing them using stannous chloride in concentrated Cl followed by acid hydrolysis to form aldehydes. Then second one is Rosenman's reduction. So in Rosenman's reduction, acid chloride is heated with hydrogen in the presence of palladium catalyst supported over barium sulfate. So aldehyde is formed there. So no need to write any example. Okay. So if it is given in your NCERT book, then write the example. Otherwise, if you get a question like what is Rosenman's reduction, so directly you can write when an acid chloride reacts with hydrogen, when it is heated with hydrogen in the presence of palladium supported over barium sulfate, it forms aldehyde. Next one is Itard's reaction. Okay, in Itard's reaction, so any methyl group of the toluene, so not only toluene, so if the benzene ring has a methyl group, then that methyl group can be converted to aldehyde group by using chromyl chloride. So this chromyl chloride oxidizes methyl group of toluene. So this toluene to form a complex. So this is complex. So which on hydrolysis gives benzaldehyde. So you get two questions. ಇಲ್ಲಿಂದ ನಿಮಗೆ ಎರಡು ಕ್ವೆಶನ್ಸ್ ಬರ್ತದೆ. ಸೊ ಏನು ಎರಡು ಕ್ವೆಶನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಎಕ್ಸ್ಪ್ಲೇನ್ ಎಟಾರ್ಸ್ ರಿಯಾಕ್ಷನ್ ವಿತ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್, ಯು ಮೇ ಗೆಟ್ ಕ್ವೆಶನ್, ಆರ್ what is the reagent used in the Itard's reaction. You have to write chromyl chloride, and never forget to write these solvents, because solvents plays very important role. Okay. So instead of chromyl chloride, so you can use chromic acid also. So toluene is converted to benzylidene diacetate. So this is benzylidene diacetate, and it is treated with chromic oxide in acetic anhydride. So at 273 to 283 Kelvin, which on hydrolysis forms benzaldehyde.